Hello, everyone. Welcome to our 5th webinar.
Hello, everyone. My name is Nia Remes. I'm colleague with Jean Zaganel, and we are working at Cendio together with ThinLinc, and we want to welcome you this webinar today.
Thanks, Nia. My name is Jean Zaganel, and we are happy to host this webinar today. We hope you have a good session, and thank you all for attending. So the webinar today the topic is interactive high-performance computing using ThinLinc, and the presenter is Dr. Richard Martin from University of Strathclyde. And the webinar today is part of the extended program from Computing Insight UK 2020. So thanks also CI UK 2020. Why are we here today? So everything started in February 2020, when a group of academics submitted a proposal for a BOF proposal for ISC, and they had the common interest to discuss the topic, interactive supercomputers. The plans for ISC changed. However, the interest in the topic remained. So as a consequence, these HPC webinars started there and are happening now. And we want to express our gratitude for their effort and for all other presenters. So Bernd Daman presented in April. In June, we had Robert Henschel from Indiana. In August, Anders and Jonas from Lund. And now in October, Kevin Colby from Purdue. So thanks all of you. And today, the 5th webinar with Richard. Here we have the abstract that all of you, I think, had access by email when registering. So interactive high-performance computing using ThinLinc. The presenter, Dr. Richard Martin. So he's high-performance computing manager at ARCHIE-WeSt, University of Strathclyde. Short bio from Richard. I think he will present himself. Am I right, Richard? Are you listening?
Yeah, I'm listening.
Perfect. So, just a little bit of information about our session today. So estimated total time is 60 minutes, being more or less half for presentation and demo and the remaining for discussion. If there is interest in continuing the discussion after the 60 minutes, you are welcome to stay. We record the session, however, we will only be public shared once we have the express permission from everyone that has been active in the session. So we invite the audience, well, to turn off the microphone. It's not the case now. I think it's already off, to not have noise pollution. And please take some notes and bring them to the discussion after. Your active participation is welcome and enriches the discussion. You may contribute directly, if possible, or write down in the chat or Q&A. If you want to do the question using your voice, just please ask and we turn your microphone on. Yes, so Richard, I think the presentation starts now. Are you there? Great.
Yes, I'm here. Thank you. I'll just get my slides then. Okay. Well, thank you very much for the introduction, and thank you for asking me to take part today. And I'm going to speak about interactive high-performance computing using ThinLinc. And of course, we use ThinLinc at ARCHIE-WeSt. I'm the high-performance computing manager for ARCHIE-WeSt, based at the University of Strathclyde in Glasgow. And I've been supporting research computing in general and HPC latterly. I've been doing that at Strathclyde since around 1997, after I completed my PhD in computational physics. And so I've been closely involved in the evolution and the growth of high performance computing at Strathclyde and across the west of Scotland via ARCHIE-WeSt over the years. So, okay. Oh, there we go. Okay, so ARCHIE-WeSt. ARCHIE-WeSt is a fairly modest HPC which is currently installed at Strathclyde, and I should have pointed out that in the previous slide that we support or provide HPC resources to the institutions across the west of Scotland, including the University of Glasgow, Glasgow Caledonian University, the University of Stirling, and the University of the West of Scotland, as well as the industrial community as well. As I said, it's a fairly modest machine, Lenovo hardware installed by OCF. We have 64 standard compute nodes, comprising of 2 Intel Xeon Skylake CPUs, 40 cores on a node, 2,500 cores in total across the cluster, 192 gigabytes of RAM on each node. We have 2 large memory nodes, each with about 3 terabytes of RAM for those that require that amount of RAM. A couple of head nodes for system management, which is on a virtual infrastructure, a high performance network, and 230 terabytes of high performance parallel storage, and we're just in the process of expanding that to about almost a petabyte. But the most significant thing is the fact that we have 4 visualization capable login nodes at the front end, and I'll come back to that and discuss that in more detail later. And that's really the most important part of today's presentation. We've added recently high-end graphics cards. We have 4 V100 GPUs, and we're just about to install 8 A100 NVIDIA GPUs to support the growing activity in AI and big data. ARCHIE-WeSt has been very successful, I would say, in our region. We have 280 active users in the course of a year, and we've had over 800 users in total since 2012. We've supported about 380 PhD projects, so that's about half of our user base are postgraduate students. And so it's probably no surprise to you then that the majority of our users are first-time users of HPC. So we've spent an awful lot of effort over the years training and inducting new users into HPC. So we don't have a kind of long-established traditional HPC user base. Our researchers have produced somewhere in the region of 600 or so journal and conference papers, which we do our best to record on our system, our pure system in the university, at least as far as Strathclyde publications are concerned. So Strathclyde has generated at least 468 research outputs, probably more than that. I have no doubt that there's stuff missing from here. But we also try and track what our partners produce as well by picking them up from Google Scholar. So we know that we've at least been involved in generating 600 research outputs, which is very good. And it's important for us to have that kind of information when we are making business cases to the university for funding and so on. It's quite important that we can prove our worth, as it were. So as far as the interactive HPC is concerned, we have a significant demand for interactive access to high performance computing. And a lot of that stems from the fact that I would say that we have a very diverse, and possibly you could describe as being a non-traditional user base. And we have a lot of requirements for commercial software, for users to run commercial software, which have graphical user interfaces and GUI-based workflows. And so for that kind of user base with those kind of requirements, command line only access to HPC would be a major impediment to its utilization. And I have no doubt that our utilization would be much, much lower without interactive HPC capability. And it's not just about this issue of users coming from a Windows background, though that is a factor. I think there's a danger sometimes that we overstate that problem. It can be a problem. Sometimes users are not terribly enthusiastic about having to learn the command line. But I think our experience has been that where there is a requirement, people will be open to being trained in the basics of Linux in order for them to be able to access high performance computing. So when we train our users, for those who require it, for those who need it, we would give a short introduction to Linux, and then we would train them on how to drive the HPC, if you like. And the vast majority of our user base, those 800 users, have been through that training one way or another in the last 8 years or so. So the Windows to Linux thing is an issue, but I think the biggest driver for interactive HPC is the software and the workflows associated with that software. A large proportion of our users come from the engineering faculty, and so they need to use the tools that are commonplace in that area, like ANSYS and Abacus and so on. And command line only driven HPC is not ideal for a user base like that. In addition, there is of course a requirement for visualization, and so that also increases the need for interactive HPC. Now, back in the day, when even prior to the installation of ARCHIE-WeSt in 2012, in our earlier HPC systems, our users were encouraged to post-process on their workstation. So the working model was that they would run their stuff on the HPC, and then they would copy the data back to their workstation and do the post-processing there. However, it wasn't really very long before we were getting people phoning up saying, well, I generated this data set and I copied it to my workstation, and I opened it up and my workstation crashed. It turned out they didn't have the RAM, they didn't have the resources to be able to work with the data that they were generating on the HPC. So this post-processing on the local desktop idea really proved to be non-viable. And therefore, we had the requirement for the visualization to be performed remotely, where the data is. So that the idea is that you keep the data in its location on the HPC and you go to where the data is, and that's where you perform your post-processing and your visualization. So like a lot of centers, we installed a couple of visualization servers, hardware accelerated visualization servers with graphics cards installed, and they were accessed using Turbo VNC, which worked with virtual GL. So the benefit is obvious. There's no need to transfer data, and then there's also no need for high-end local workstations if the post-processing is done on beefier servers elsewhere on the campus. But then when we refreshed ARCHIE-WeSt, in our first installation of ARCHIE-WeSt, we had 4 login nodes, and these were accessed using NoMachine NX for remote desktop access. But allied to that, we had our 2 visualization servers. So we had 6 front-end servers, 4 regular login nodes, and 2 hardware accelerated visualization servers. And when it was installed, NoMachine was the remote desktop infrastructure that was installed. That was a free implementation of NoMachine NX version 3, I think. And it was okay. It had some nice features that we became accustomed to. The connection was across SSH, so there was no issue with additional ports having to be opened up in firewalls. User sessions were created automatically. The load was balanced across our login servers. To be honest, I was discussing with my system administrator this morning and can't quite actually remember if there was virtual GL support in NoMachine at that time. But even if there was, we were running our visualization servers separately using Turbo VNC. But it also had multi-platform clients, which were free to the end user. And by and large, it worked very well. However, having separate visualization servers was a bit of a nuisance, because it then meant that the users, their activity could be split across two different types of front-end login node. There was the regular login node that they could set up jobs and run jobs. But then if they wanted to do visualization, they had to close that session and open up another one on the visualization server. And that was inconvenient, sometimes causing confusion when things went wrong and they had to call for some support. But then on top of that, the free version of NoMachine, the NoMachine client, became too out of date. We started to encounter problems. I think for some platforms, they rolled out version 4. You couldn't get version 3 anymore for the Mac, for example. And it didn't work terribly well with the version 3 infrastructure. And it just became difficult to support. The way to solve it, or one way to solve it, would have been to purchase the commercial version, but that was prohibitively expensive. If I remember correctly, the pricing was based on the core count on the server. So if you have fairly beefy login nodes and you have 4 of them, it becomes expensive very quickly if your pricing is based on that kind of model. So we were looking for an alternative to NoMachine around about 2014. And at that point, we were in the process of refreshing the operating system environment on Archie. So we looked around for an alternative, and that's when we came across ThinLinc, which seemed to cover all the bases. It gave us all the features that we were looking for, that we were accustomed to, like secure, worked across secure shell. It provided us with automatic session creation. It load balanced across the login nodes. It supported accelerated OpenGL through virtual GL. There were clients available for all the platforms that we needed them for. It was free to the end user. We didn't want to push any license costs onto the end user. But on top of that, as well as all of that, those necessary features also came with session management and administration tools. And the licensing was much, much more affordable, based on per seat licensing rather than core count. And you could even install a test implementation up to 10 users. And so this seemed to tick all the boxes, and we purchased some licenses, which as I said, were very affordable. And we don't mind purchasing commercial software where it is necessary and where it provides advantage. So we implemented ThinLinc in 2014, and it has been very, very stable, and very good and popular with ourselves and with the end users. I'm just going to let you see some of the admin interfaces that are available. As you can see, it's web-based, and here you can overview the license usage. Just check that you're not running out of licenses. See what the activity is. You can also look at the load. Keep an eye on the load on your servers. I've only got 3 login servers here. One of them is out for maintenance at the moment. But the most useful thing is the fact that you can access the sessions of your users. And here all of the sessions are listed individually, though I've blurred out the usernames. And if you have a problem with a particular user, for example, then you can click into their session and find out details about when it was created. Are they connected? Are they disconnected? When did they last connect? And then you have the power, should you require it, to terminate the session. Now, quite often we use this, not so much for users who are misbehaving, but the most common use here is when something goes wrong in a desktop session, the window manager crashes or whatever, and the best thing to do is just terminate the session, kill off any remaining processes, and then the user can log in and get a fresh desktop. And that's very, very useful. So as I said before, we have a very diverse user base with a large requirement for commercial graphical user interface driven software. These are some of the ones that we use, the usual actors, I guess. ANSYS is heavily used by mechanical engineering and naval architecture, both with ANSYS Mechanical and Fluent. Gauss View for the quantum chemists, COMSOL, MATLAB, Abacus for finite element analysis, and StarCCM is another CFD package which is heavily used by naval architecture. And then on top of that, there are the usual visualization, free or open source visualization packages like Visit, VMD, and ParaView. And out of those three, VMD is the one which is most heavily used on Archie. So to go back to our login nodes, all of our login nodes are visualization capable, and that's a decision we took when we refreshed ARCHIE-WeSt in 2018. So we put the system out to tender, and we decided at that point that we wanted to move away from this model of having 4 regular login servers for command line driven stuff or some graphical stuff, and as well as that having separate visualization servers. We wanted to simplify things, and it occurred to us when we did a bit of analysis that in actual fact on the visualization servers, even when running things like VMD or other visualization programs, the onboard graphics cards actually really weren't being used all that heavily. They were barely breaking a sweat. And so at that time we had some pretty high-end graphics cards in those servers which cost several £1000s. So it occurred to us that was actually quite an expensive and unnecessary model. And it was much better to invest the money in the login nodes, beef up the login nodes, install more modest graphics cards, and do away with this distinction between non-visualization access and visualization access. So we specified our login nodes with that in mind. So we have login nodes with 2 Intel Xeon CPUs, just the same as the rest of our cluster, but more significantly beefed up RAM, 768 gigabytes of RAM, which is necessary for running lots of desktop sessions. It seemed to us that that was really the greatest requirement, and as well as having an onboard graphics card, but a fairly modest graphics card. Rather than spending thousands, you could spend just or sub-thousand, a few hundred pounds for a graphics card. And then, of course, these login nodes are ThinLinc enabled, so we're running the ThinLinc infrastructure across our 4 login nodes. And this has proved to be very successful and very popular with our users. We do, of course, allow just regular SSH access for command line work, but I think this gives the best of both worlds. It gives you command line access, it gives you remote desktop access, and it also gives you visualization capability. And the users don't have to switch from one server to another, depending on what they're doing. And you don't need to spend a fortune on graphics cards. When we wrote the tender, we couldn't specify a particular product. So what we did was we said, right, in these login nodes, we just want a single slot graphics card because we knew that would limit the options. But nonetheless, one vendor came back to us and said, oh, well, we'd like to install a dual slot graphics card. Can we do that? So we replied and said, no, you can't. They kind of missed the point. So by restricting the tender to a single slot graphics card, that ensured they didn't overspend or overspec the graphics card. There are other options, of course. There is I think an NVIDIA M4 I was told about this morning, which may be a better option, but this graphics card has worked well for us. Caveats. The only caveat that we could really think of was that you're limited in the desktop that you can run. GNOME 3 is not ideal. It tends to require hardware acceleration, which I don't think you could get to work with VirtualGL. But in any case, it's resource heavy, so we opted, probably like most places, to roll out the Mate desktop, and the users seem to be happy with that. But apart from that, we can't really think of any real significant caveats to this approach, and so it's one that I would advocate, that if we are interested in increasing the reach of HPC to accommodate the widest user base that we can, to support the widest range of software that we can, then I think this is a good approach. A lot of places still seem to use this split model of regular login nodes and visualization capable login nodes, but really there's no cost benefit to that either. It's better investing in the login nodes, and overall I think it gives a better user experience. So at this point, this slide is to remind me that this is where I do the demo. So this is where it could all go horribly wrong. They say not to work with children and animals, but I think they should probably add to that live remote desktop demonstrations, but we'll give it a go and we'll see what happens. Okay, so hopefully you can then see the ThinLinc client. This is what the user sees when they start up the ThinLinc client. So of course they can just type in the name of their server, their username, their password. If you want to kill off an existing session, you can do that. But I thought I'd just show you briefly the options that are available to you. The most significant ones being the screen optimization and security. So here you can change your resolution. The one that I like the best is this work area maximized option, which maximizes the desktop to almost full screen, but it doesn't obscure your taskbar. So you still have access to your Windows taskbar or your Linux taskbar, and that's quite convenient. You can of course play around with the optimization, with the compression, and you can change your security sessions. The default, of course, is just SSH access across port 22. Okay, now let me close that, and I'll show you our desktop session, which I prepared earlier. So here's my desktop session on Archie, and I'm just going to quickly show you 3 of the applications running that are most commonly used on Archie. First of these being VMD, and I'm going to load up a visualization state that's helpfully supplied by one of my colleagues. So this is a output from an AMD simulation of a protein interacting with a surface, and that's probably about as much as I can tell you. Now, hopefully, what you can see is close to what I can see in terms of performance. But for me, the performance is excellent. The performance is working very, very well. You can even switch on the animation to see the movement of the ions, the blue ions and the yellow ions. And it's really quite smooth. Now, what I haven't told you is that I'm delivering this seminar from home. So I've been working from home since March. And so I'm viewing this across my home broadband, and then obviously sharing it back to you across Zoom. And so the performance, really, the accelerated graphics performance really is very good, very usable, and you can operate from home, quite the thing. Another thing that you might be interested to know is that I'm also doing this across 4G because of the distance I am from the telephone exchange. The landline that I had the performance was terrible. My broadband performance was awful. So I eventually ditched the landline and moved to 4G broadband. So this has been conducted across a 4G network. And I hope that you get a good feel for how well this is working. I'm going to close down VMD. So that's a standard sort of example of visualization. Another popular program which is used very often is Fluent. I loaded this up earlier because it's quite a large data set and takes quite a wee while to load. So the user can load up their mesh, they can work with their mesh. And then the way that they usually work with Fluent is that they would prepare the mesh or do whatever they need to do with the model or post-process or whatever. And then if they need to run a calculation, they would save the case file and then submit the case file to the queue, to the standard nodes for calculation. And so that's maybe, if you like, a kind of hybrid mode, if you like, combination of both using a graphical front end and also command line stuff for interacting with the batch queue. But another way, and another kind of mode of working is demonstrated by StarCCM, which again is a CFD program used heavily by our naval architecture people. But one of the nice things about, or at least one of the things that our users like to do with the Sim Center StarCCM GUI is connect to simulations that are actually running on the queue. So they may have already submitted a job to the queue in the usual way through the batch system, which is Slurm, and it's running somewhere on the cluster on one of the nodes, and then they want to monitor progress, and so they can connect to the server. Now the one that I've got running just now is in node 24. So this just connects up to the simulation that's running in node 24 and gives them access to a whole variety of stuff. They can plot various outputs. They can look at residuals from the simulation, and they get the data is updated in real time, or they can look at their geometries, and again this is really quite responsive and performant. And so the users are use this mode of working quite a lot, and it seems to be popular and work quite well. So I just disconnect from that, and the simulation continues to run on the standard node. So that's just an example of how the remote desktop session can be used by the users. So let me go back to my slides. Okay. So in terms of how things have worked in recent days, well, of course, the vast majority of us have been working from home, certainly in the UK. And this infrastructure and this configuration that we have has actually proved to be a bit of a lifesaver for our researchers who have moved to home working. And because really there has been little or no change to the way that they work. Now, I know you can say that about HPC in general, especially if all you need is a command line. It makes no difference whether you're at home or you're in the office. But if you're working with graphical applications, then it can make a big difference. And if, for example, you're working on campus and relying on X11 forwarding, that's really not a viable model for home working. Whereas ThinLinc with the visualization front ends and the graphical desktops has worked very, very well indeed. And really there was no interruption to our users' workflows at all during the last few months. And for them, it's really just been business as usual. And so that's something we were really pleased about. And I think reinforces to us the value of this approach, this kind of interactive HPC approach. And it's certainly a model that I think we will be continuing with into the future. And ThinLinc for us is an ideal product. It works very well and it's affordable. There may be other alternatives out there which will do the job as well. That may well be the case, but ThinLinc has worked very well for us, and has provided their users with a very stable, robust and performant solution. And there are some things on our wish list. Could ThinLinc be improved? It could be improved for where high-res displays are concerned. I think this is mainly an issue for Linux clients. you really don't want to be sending a 4K desktop across the network. So if you want to view a desktop on a high-res display, then pixel scaling would be convenient. And also it would be quite nice just to have integrated hardware, OpenGL hardware acceleration directly built into ThinLinc rather than relying on virtual GL. I know that there is one other, at least one other product out there where hardware acceleration is built in to the client. So you don't have to type virtual GL or VGL run before you run or before you launch your application. So that would be quite nice. But these are relatively minor things. So really that's all that I have to say today. I hope that has been informative and useful and interesting, and I'd be happy to take any questions at this point in time. Thank you.
Great presentation, Richard. Thanks. And yes, so we'll share the screen. Presentation is done, discussion as well. We are happy to announce the beginning of our local operations in the United States, and we welcome Pontus Anderson to our team. So now there is a direct contact and local in US. You are welcome to contact Pontus on any need of technical or commercial discussions. Another announcement, something new, my colleague Aaron sent it today. We invite all of you to join the community. So we are pleased to announce the ThinLinc Community Forum. It's a space for learning and discussion around ThinLinc-based solutions. Become a member at community.thinlinc.com. So you are welcome to join. We are still in the beginning, populating the community, and your contribution helps a lot. So welcome to join. Well, thanks for joining this webinar, all attendees. Thanks for the good discussion. Thanks, Dr. Richard Martin, for the great presentation, for your time. And I think it was very helpful. Would we also invite other ThinLinc users, customers? Would you like to present your ideas? You are welcome to join and share your thoughts and feedback with us. There is Aaron's email and mine.
Thank you very much for attending today at this webinar. Thank you, Richard.
Thank you. Thank you very much for inviting me to speak.
Thank you.
So I wish all of you a great rest of the day, and we meet each other in our next sessions. Bye-bye.
Thank you.
Bye-bye.
Bye. Bye-bye.